Hi. From this video and other upcoming videos, we're gonna talk a lot about linear algebra. Linear algebra is a really interesting topic, and it is definitely one of those essential requirements if you are gonna go into any STEM fields. So, okay, let's get into it. And today we're gonna talk about two basic topics: the uniqueness and consistency, and the echelon form and the reduced form of a matrix. So what is actually a matrix? Let me write out the matrix here, right? 1, -2, 1. Second one is. So how do you actually interpret a matrix like this? Basically, matrix is just a simplified form of a system of linear equations. So if you actually translate it, it would look something like this. In the first equation, x1 is x2 plus third variable to 0. And because it's 0 here, which means the coefficients of the first variable in the second equation is 0, which means the second equation doesn't contain any first variable at all. And so it will be something like this. Plus 0 and minus third variable is equal to 10. So here is the system of linear equation. So at this point, it seems really familiar to you because we've all done some solving of a system of linear equations before, and it's some knowledge that we got way back. But although it's a pretty easy topic because this is just the entry of the linear algebra. However, linear algebra it takes a really different approach to solve this kind of problem. So basically, you have to start with one equation here. Okay, so this is the first row, this is the second row, and this is the third row. Among these three equations, you have to choose the equation to start with to perform the further steps. So it is the best for you to choose the equation that has the most non-zero terms in it. So in this case, it will be the first equation because the first equation has 3 terms here, okay, and they don't have any zero coefficients. So, and however, and the second point is that it will be even better if you start with an equation that has the first variable has the coefficient of 1. It will be really convenient. I mean, however, to put this question in a more precisely, it's the coefficient on the pivotal positions. So as for matrix, what's the pivotal equation? What's the pivotal positions? It will be, as for the first equation, it will be here. This is the pivotal position. And as for the second equation, the pivotal position would just be the position of the second variable. Here, it will be the pivotal position. And for the third one, yeah, because we have 3 equations here, so we have 3 unknowns here. And the third pivotal position will be this one. And okay, so first, start with equation that has the most non-zero term and look at its leftmost value and see if it's 1. If it's 1, then it's much better. So, and this, I will bring up this later, so don't worry about it. And for the first equation, we're not gonna eliminate. We're gonna use the first equation to eliminate all of the first variable in other equations. So in this case, the second equation doesn't even have a first variable, so we don't need to consider about it. And now just let's look at the first equation and the third equation. They both have the first variable, and to eliminate it, need to write such equation: -1 times the first equation plus third equation, and the result equation will be, let's say, 3 prime. Okay, and 3 prime has the equation of because the first term is eliminated, so it will be -10, and -10 equal to 10. Second variable, the third variable here. Now we get a new equation here, and let's plug this equation back into the matrix, and the matrix now will be 1, -2, 0. Third equation will be 0, -10, -10, 10. So the first variable of the third equation is eliminated. So now let's move on to the second variable of the third equation. I will go here, and I will bring up this later, so just don't you worry about it. We have to get this matrix somehow into a triangular form. So basically, these 3 terms right here, we're gonna try to make them 0. And left the third equation only with this variable and this constant value here. So let's do this. So to eliminate the second variable, we're gonna look at the third variable, a third equation and the second equation here. So it will be the 5 times of the second equation plus the third equation. It will be 0, 0, and -50 here, equal to -50, which means -50 times the third variable will be 50, which gives us the value of the third variable, which is -1. So after having this value, we can plug the third variable back into other equations and find the constant value of the first variable and the second variable. And now we'll get to the second topic here. It will be the echelon form of a matrix and a reduced form. So what will be the resulting matrix here? The resulting matrix will be 1, -2, 1, 0, and 0 to -8, 8, and 0, 0, -1, 1. So here's a matrix that looks kind of different from the first matrix, right? Because it has its 3 terms here, 0, and it is pretty important because this is the form what we call the echelon form of a matrix, and the application of it will come up later. And now we just need to know that this is the echelon form of a matrix. It is, however, this is not a reduced form of a echelon matrix. And also, we have some definitions for this echelon matrix. Basically, all of the equations that has the most non-zero term should be the first equation here, and the second equation that has the second most non-zero term will be the second equation, will be the second row here, and goes on and on. So this is the first rule. This is the first definition, and the second definition is that the entry value, the entry value of any row in a matrix is the leftmost value here. These are the entry value, and entry value also has a name of pivotal value because they are on the pivotal positions. In the echelon form, any value, any number that is at the leftmost position of the row, okay, at the leftmost position of the row will be the pivotal value. And these three are the pivotal positions here, pivotal. And okay, so this is the second definition. And the third definition will be anything below in a column. Okay, in a column, anything below the entry value should be 0. Like here are two 0 values. Here are two 0 values. And okay, so these three definitions are the definitions for echelon matrix. The first one is okay. Let's just not repeat it again. And then now we can get to the second form. The second form is the reduced echelon form. Reduced echelon form has only one difference. Okay, so every number on the pivotal positions should be 1. Let's give it an example here. Like 1, 0, 0, A. 0, 1, 0, B, and 0, 0, 1, C. Basically, this is just the solution set, okay? So the first variable has its value A, and the second variable has the value of B, and the third variable has the value of C. This is basically just the solution set, but this is called the reduced matrix, reduced echelon form of a matrix. Okay, so today we just gone through like 3 different definitions, and that is not a lot. And see you guys in the next video. Hope this video is helpful. Thank you for watching.